here. This is my first Zoom, so
Oh, it is? Okay.
gotta get on your level, you know.
Yeah.
All
All
right,
right. Let me add this to the story.
cool, no
Go
problem.
for it. Yeah, I'm ready when you are, man.
Awesome.
Sorry I'm late.
No worries. Just want to introduce you to my fan base. This is Dr. Brian Keating, distinguished professor of physics at UCSD. He's the inventor of the BICEP telescope, which we'll be talking about, and the fearless host of my favorite podcast, Into the Impossible. I just want to start off by saying congratulations on 100 episodes.
Thank you.
Trying to get through them all, through this quarantine. They've really, I've learned a lot.
Pandemic podcast. That's what I call it. The pandemic podcast.
Yes. And I've also been reading your book, Losing the Nobel Prize, which I'm on my third pass of it. And let me,
That's more than I read it.
Well, this time, what I'm doing is I'm actually highlighting everything with a format. Because
Nice.
one of the questions that I had for you was when I first read it, I pictured it in my mind as a movie right away, and I was like, oh, there's an amazing story here. Maybe we can talk about it a little more as we go on.
Yeah, absolutely.
I like how you've documented not only history but your legacy and been able to articulate to the layperson a perfect image of how things work as a physicist, astrophysicist, or cosmetologist. I mean, cosmologist,
That's my joke.
Yeah.
Stealing my best lines.
So yeah, I love the book, and thank you for contributing that to society and history. So just
Thank
wanted
you.
to start off by
Yeah,
saying that. Yeah.
you definitely are one of the intended audience targets that I wrote the book for. Young people that aspire to do great things, and sometimes we come up short. Sometimes we're perfectly imperfect, but we all got to keep the struggle alive.
Well, you have 5 children, and that you said that. How so? I have siblings. I'm the oldest of 7, and my youngest siblings 14, 15 years old. So how are you getting your children interested in this field, or how do you motivate young people to pursue that passion in physics specifically?
Yeah, well, some of them are too young to appreciate physics, so they're just doing quantitative biology at this point. When they're 2 years old, it's a little hard to do physics. No, I'm just kidding. The very young ones are not doing anything,
Yeah,
but they're
unless you're
just
Stephen
curious.
Wolfram or something.
And that's right. Yeah, he's doing quantum physics for his junior high school science fair. He's an exception. But yeah, my kids are the one thing I want to stoke in my kids is curiosity. So today I was driving them to school. One of them kept me up late with my wife, and today I'm just kind of bleary eyed. And then my 8-year-old, he's just like, Daddy, is it possible for like a sonic black hole to suck in sound? Another one's asking me, what's it like if the ocean had no salt in it, if it was fresh water, would the waves be as big as they are? And I'm like, I don't know, actually. That's a very good question, but that's a scientific question.
Yeah.
And so the one thing I don't want to say is yes. Next question. Basically, I want to encourage them to keep asking questions. I always say to my graduate students, I've had 14 graduate students in the last 16 years. I'm pretty blessed to say that. Very few people have that many graduate students as me. And these are young people, younger than you even, that put their trust in my leadership and my stewardship. And I always say to them, my job is to get you to your next job, but then it's your job after that. And that can only be accomplished, especially in this economy, by maintaining a curious, relentless passion for learning. And we'll talk maybe a little bit later about the difference between knowledge and wisdom, because I try to cultivate that in my kids as well.
Okay. Do you think that curiosity is somehow sparked with like creativity too? How do they go hand in hand, or?
Yeah, well, people don't usually think of physics as like a creative sport. Like behind me, I've got this amazing painting, if you can see that back there,
Oh.
by the host today. So I look to art for inspiration. I look to nature for kind of not guidance on how to be wise, but to be curious. So
Mm,
nature is written in the language of mathematics. That's what my friend Galileo Galilei used to
mm,
say, that the language, the book of nature is written in the language of mathematics. So to
okay.
understand, you have to know some mathematics, or at least appreciate mathematics. That's the baseline.
Mm,
You can be curious about mathematics. You can do a lot without being Stephen Wolfram or Eric Weinstein,
mm,
but the bottom line is you have to have a baseline familiarity with mathematics. What I find unfortunate is that physicists in particular disparage philosophy.
mm.
Philosophy, I don't know if you know this, but
Oh yeah.
philosophy means love of knowledge.
Yes.
So it's amazing, because why would you not want to love knowledge? So
Mm,
I have people that say things not on my show because I don't have them out, like Lawrence Krauss. You know, he basically thinks that philosophy is totally worthless, and I think in those types of instances, you know, you get what you pay for. If you're not willing to consider the deepest questions as having a value in and of themselves,
mm,
if only things are worthy of investigating, if they can be looked at mathematically, I
mm,
think we've got a big problem. So my main thing is to be curious. I think the first people that were curious were philosophers. I don't think that, you know, Lawrence Krauss or even me or somebody is wiser than Aristotle, and Aristotle didn't have access to a Large Hadron Collider. So I
right.
don't think it's fair to denigrate philosophy. In fact, I think it's the underpinning of all of math, which is the underpinning of physics. So curiosity plus philosophy can probably get you past the hurdle of mathematics, but I'll say for sure you can't succeed as a scientist without curiosity, and oftentimes it does, as you hinted at, lead to creativity as well, mathematically, physically, and otherwise.
Where did that line in philosophy get blurred? Because then you got Aristotle has, contributed to music, for example, with the sound waves, and Galileo, his father was a musician as well. But so it's like, when did philosophers separate and then physicists evolved?
Yeah, that's a good question. I've got a book on my couch over here. I can't see it, but I'll bring it over. It's by Frank Wilczek, who won the 2004 Nobel Prize in physics. I almost picked up this book by accident, which is full of wisdom. Also, I'm writing my second book, is going to be kind of a knockoff of Tim Ferriss's Tools of Titans,
Mm-hmm.
calling it Lessons of Laureates, or Lessons from Laureates, or Think Like a Nobel Prize Winner. We'll talk about that later. But getting back
Awesome.
to to the ancient Greeks, so you got an exclusive there, Miguel.
Mm-hmm.
So Frank Wilczek, who won the Nobel Prize, I said, he talks about philosophy for about half of this book, which is a wonderful book. He was on my podcast, Into the Impossible podcast, just last week, and he looks at all the ways that art, music even, are influencing and
Mm-hmm.
influence physicists. So here's Newton's experiments with prisms over here, color, and then a manifest of color in great art,
Mm-hmm.
and how you could even look at principles in physics that he studied, which is called complementarity, and look at, when you pick, as you know, you take the different colors
Mm-hmm.
and you add or
Color.
subtract them,
Mm-hmm.
that has a physical effect.
Okay.
So here, where this wheel is over here, is like a color wheel that you can spin, and people did experiments on colors for many, many years. And then he'll look at famous paintings. Let's see, I'm trying to find the one that he and I talked about.
Mm-hmm.
But you'll look at paintings where you can transpose the different colors, and you'll get a totally different image. And I think that's really fascinating to me, and how you can experiment with complementarity, and even from like an Eastern tradition, the yin yang symbol, etc. So he looks at that, and he asks the question of, how far back does beauty go? And beauty goes all the way back to the ancient Greeks.
Mm-hmm.
So he talks about Pythagoras and the harmonies of different strings, and Pythagorean ratios and chords and stuff. Much better than me. I always joke that the only instrument I play is the iPhone. That's all I can play. I don't have a billionth of your talent. But from the ancient Greeks to today, there's always been this deep link between music and art and science. In fact, one of my best friend, Professor Stefan Alexander wrote a book I'm going to go grab in the back.
The Jazz of Physics.
Where is it? Here it is. See how many books I've got, Miguel? I've read 41 books since the pandemic kicked in. I've had 41 podcasts. But my best friend from graduate school is a man by the name of Professor Stefan Alexander. Stefan's at Brown University.
Yes.
You should get this book. I'll send you this book, actually.
I have this
Miguel,
book.
I'll send you. Oh, you have his book. Awesome, brother.
Not only that,
great.
but I bought I bought a used copy, and it's signed.
Oh, awesome. Oh, well, that is awesome.
Phenomenal.
I hope it's not like I actually bought a book once bought a copy of my book, Losing the Nobel Prize, on Amazon, used because I need an extra copy. Yeah. And it was signed and it said, Dear Liz, I'm so glad to have you as a friend. And I'm like, this person freaking sold my book. But anyway, as you know, Stefan talks about this deep link going back to the Greeks and in music and in science, and how the universe and his conception is a form of improvisation, and the laws of physics as constituted by people like Richard Feynman and Murray Gell-Mann and others manifest a beautiful musical symmetry that we can actually tap into using different kind of sensorial mechanisms like our eyes and our ears.
So that plays into two things. You stumped me a few months ago. You asked me to paint or illustrate the multiverse. So when I started trying to conceptualize what that could be in my interpretation, I started to I went back to my first spark. There's three instances of my life that sparked my love and passion for music and sound, and one of those was when my mom, for my first grade science project, was she's former member of a choir in Puerto Rico, and my grandma founded it. And so my mom sang at Carnegie Hall when she was 8 years old, and she's managed a bunch of artists. And so my mom says, for your science experiment, she goes, when you take a sword and you just whoosh, and you whoosh it, and you got that sound, well, that's because of the motion, and the planets probably have a tone. And I'm like,
going back, Kepler would be proud of mom.
And I was like,
that's awesome.
It's the scale. It's the whole scale. 8 planets, 8 notes. So, so that started my interest and passion in pursuing what that mystery is, and I think that plays into the whole multiverse theories and concepts, how and also to the creation, which is also I wanted to talk to you about, with the CMB and inflation, and it's like, how much does sound play into that, and is like, how are we just not capturing, because I know it's electromagnetic disruptions that you can calculate what the tone is. It's like, got it, but are our instruments not to the point where we can hear those tones yet, or how does that play into?
Yeah, it's very interesting. We started to listen in on the universe literally through the LIGO experiment. It did something that we had never done before, exactly akin to what Galileo did back in 1610 when he used his little telescope here. Which again, this is the Christmas season. I'm often asked, what kind of telescope you should get for kids. So get anything. I got to come out with it. We got to come out with the Tully Keating telescope, painted bespoke telescope, because I get asked so much for that. We got to have some merch. Absolutely. Monetization is the future of our podcast, man. But anyway, so I look at it and I think it's basically, I don't want to say it's a crime, but if you have kids or kids, you should get them a telescope, because when I was a kid at age 13, I got my first telescope, and 12, 13, and I didn't live, on the top of Mauna Kea or in Arecibo or, wherever. I lived in the middle, just north of New York City, in the biggest metropolis in the country. And I could see the same craters on the moon, the phases of Venus, eclipses of the sun. I could see all the same things that Galileo could see 400 years ago. And that inspired in me. I often say, you can't possibly replicate the feeling of discovering the Higgs boson. I don't care who you are. First of all, it took 6,000 people, 20 years, and 25 billion euros to do that, right? But you can exactly feel the emotion that Galileo had when he looked and saw the moon was pockmarked with craters, or Jupiter had moons orbiting around it. I want to encourage people to go out tonight and look towards the setting sun. About half an hour after the sun sets, you'll see the moon, and you'll see two planets. You'll see two bright planets. They're about to merge almost in an event on Monday the 21st, the first day of winter in the northern hemisphere. And I always have to caution that because I have a lot of listeners at the South Pole. So I have to say it's the first day of summer for you brothers down there, but for us up here, we gotta get ready for a long winter ahead of us. But
that's
anyway,
Jupiter.
It's Jupiter and Saturn. Yeah, they're coming together. They're making what's called a conjunction. And those two planets, if you have a small telescope, just whip it out, or even binoculars. You'll see the rings of Saturn, the craters on the moon. The moon's been illuminated with Earthshine, which is light that's reflected from the sun, hits the Earth, bounces to the moon, bounces back to the Earth. It's unbelievable. That's how you can see the unilluminated side of the moon, even tonight, perhaps, if it's clear where you're at. Anyway, LIGO, what they did is they looked and they found that the universe had distinct sounds. It had tones that it was playing, and these tones happen every couple of months. They'll hear this very interesting sound, which I have on my you have on your DJ equipment, that's kind of like the whoop whoop whoop, to chirp. You could probably lay one of those out right now. Actually, you should put that in. I want to hear that one of your tracks, brother. I want to hear you put in the LIGO chirp, okay?
Absolutely.
Because you can hear it.
I'll put that.
You can hear two objects 30 times more massive than the sun, going half the speed of light, colliding together to make an object that's 59 times the mass of the sun. So there's one mass of the entire sun that dissipated throughout the universe in the form of waves of gravity. And you can hear those waves of gravity as they enter laboratories in Washington State and Louisiana. And they made a cell phone ringtone based on it. And you can put it into your music. I'd love to hear something inspired by the sounds of the universe. And just to close that out, my good friend Jana Levin, professor at Barnard and Columbia College, she wrote a book called Black Hole Blues. And it's all about how challenging it was to hear the universe in sound, not light, not neutrinos, not meteorites, not even the photons from the Big Bang that I study, but to hear the reverberations of space and time itself. I can't recommend it highly enough.
Yeah, it's incredible. And I do have aspirations to, I used to do ambient albums. Stefan Alexander talks about Brian Eno, and I love his ambient work. It's like, okay, he's coined that word. So I like to merge those layers. It's like modern, but back to the telescope. So the thing that fascinates me about telescopes is that they're so simple, and so if you can talk about your BICEP telescope, how did you conceptualize the BICEP, especially that aspect, like you used milk jugs, literally in the same material.
Yeah. So
and
here's a telescope that isn't so great, but it kind of looks like a pirate's going to use this. But it's very similar to what Galileo used in 1610. You're talking 410 years ago. No one had ever thought to take this little spyglass and look up. It's crazy to think about it. But it wasn't only what he thought to do that night. He didn't invent it, but he perfected it. He made it have enough magnification. He also did some stuff to make the aperture more clear, more clean. He could make the glass really perfectly smooth and so forth. And he realized that he could improve it enough that he could see things that no person had ever seen before. And I kind of feel like, I'm not comparing myself to Galileo, but that I did the same kind of a thing. I noted that there was a type of telescope called a refracting telescope, a telescope with lenses that could measure these imprints of the early universes bursting forth in what's called inflation, this spark that ignited the Big Bang that Edwin Hubble observed with galaxies all rushing away. And what I realized is that we could do that with a small telescope, and small in astronomy equates to cheap. So this telescope has a 1-inch diameter lens.
Okay.
If you wanted to make the biggest lens type telescope ever really made, only had a diameter 40 times this. So in other words, a 40-inch lens is about this big. That telescope, this costs $10. That telescope in today's dollars would be like $100 million.
Okay.
So the size of the telescope, the price of the telescope depends on the size of the lens to the third power. So kind of like the cube of the size of the lens. So if you want to make something 40 times bigger, let's just do it 100 times bigger. You're talking about 100 cubed. So you're talking, 10 to the 8th dollars. So that's
for
where
a
I get the
small
100 million.
Spot also.
Yes.
Okay. And
yes, exactly.
For my lay audience, so inflation, correct me if I'm wrong, is basically like the rapid expansion of space-time.
Correct. And if that did occur, which we don't know, we have circumstantial evidence that it occurred, but we don't have definitive proof that it occurred. So my hope was that this experiment called BICEP, which is pictured over my shoulder up here at the South Pole. Let me go. There it is. If you're watching, and that telescope is at the South Pole, the actual axis on which the Earth is spinning around on its axis every day, every 24 hours. Wow. So that telescope housed a refracting telescope with a diameter of about this big, about a foot across. And that telescope was hoped for to go back as early as we could, not really using light, although we do use the heat from the microwave background. But really what we were looking for are these waves of gravity, but not from black holes, but from the entire universe, accelerating, expanding faster than the speed of light, a trillionth of a trillionth of a trillionth of a second after the Big Bang.
Okay. So when you're using these frequencies, so the BICEP originally only had one frequency, is that correct?
Yes,
and then right. The BICEP 2
it had two in the beginning. BICEP 1 had 2, and then BICEP 2 had 1, which is weird. You'd think it would get better, but actually we reduced it for a specific reason.
Now how so is the knowledge already there that we needed to use these frequencies to see this, or was that something that you had to conceptualize? Is that like a free parameter basically?
Yeah, we knew that with BICEP 1, which is the first telescope that I invented, and really the first telescope ever uniquely deployed so that it could detect the origin of the universe through this gravitational wave signal called B mode polarization.
Right.
That telescope, I knew that we would be confronted by not only seeing the light that we wanted to see from the universe's origin, but also from other contaminating sources that are out in the cosmos. They're not like from a cell phone nearby or a microwave oven, although we do worry about things like that. But instead, we're from particles of dust, little grains smaller than these meteorites here. I think I sent you one. These tiny meteorites are the shrapnel of exploded stars. Yeah, there you go.
Yeah, my favorite object.
So they can. That's awesome. So I'm gonna get you some dust. Next gift you're gonna get in this Advent season. I'm gonna send you some meteorite powder, and what I want you to do is mix that in with your paint.
Yes.
And you could paint the BICEP.
Yes.
With cosmic dust
cool.
as on your canvas. We'll do that. Okay.
Incredible. I can't even.
That's our next project. Yes. I'm going to get that for you.
I actually.
And then I don't know. Do you do any sculpting? Sculpting?
I'm trying to. I'm trying. Well, I do also paint with dust, and so what I have series, and one of the series I did all my military. Just my military ribbons in a big abstract form, but I mixed in dust from Afghanistan, Iraq, from Korea, and from Puerto Rico, and from the U.S. Into these 5 canvases. So yeah, the mixing the stardust would be.
So it turns out that it's illegal if you own a moon rock that actually was collected by one of the astronauts. Those are property of NASA.
Wow.
I do have moon rocks. I don't know if I sent you one. If not, I'll send you one.
Okay.
I have a little tiny sliver of a moon rock that wasn't delivered by NASA. It was delivered by the U.S. Postal Service because it came from a meteorite impact, or gravity delivered it. So a meteorite hit the moon and made a crater and shot up debris from the moon. That moon dust went around the Earth, and eventually the Earth plowed into it, and a rock about twice the size of one of these guys landed in Africa.
Okay,
I bought it, and then I can grind that up. But what's interesting is that one of the astronauts in the Apollo program, they all came back deeply affected by going to the moon's surface. but they realized that one of them realized that they were allowed to keep their own spacesuits, or they were allowed to like wash it or something.
Okay.
And before this guy washed it, he was like, wait a second, I got moon dust on my spacesuit that
Yeah.
nobody's wanted to collect. And he washed off the space dust at home before he gave his spacesuit back to NASA to go to the Smithsonian or whatever.
Oh, wow.
And he took the dust and he put it into paint. So he's got lunar
Wow.
dust and paint, but you're gonna get the same thing.
Oh,
I'm
that'd
gonna
be-
give you the same thing, but
yes,
I didn't get
awesome.
it from going there.
I'd love
Anyway,
to create with that.
the reason I ask is that one project I'd love to do with you is to take some of these meteorites or this powder and melt it down,
Okay.
and I want to make meteorite rings.
Oh,
I want to make rings made of meteorite, and I want to
Okay.
engrave on them like memori morti, like you're gonna die, memento mori, or remember you're gonna die. Be stoic about life, as many people say, or that there's my catchphrase is like ad astra per pulvis, which means to the stars through the dust.
Yes.
And that I'm a biblical observant guy, and I noted back after I wrote my book, that the Bible talks about two aspects of humans being dust. Adam, the first man, the word Adam in Hebrew means dirt, because he was made from dirt. According to, I don't believe the literal interpretation of it, but I'm just saying the metaphorical, allegorical tale is very beautiful. And then what happens at the end of your life in Judaism, you're not supposed to be cremated. You're supposed to be buried and deep and just in a pine box. And that's it. No fancy mausoleum, no cremation, so that you return, as it says, to dust. And there's many examples of dust. So I realized, wow, that's kind of interesting. That means man's birth is dust. And that means man's end is dust. So all that matters, the only thing you have to do is that between two dusts, like the dust that you were formed, the dust that you're going to come. And it really was powerful to me, especially since dust was the obstacle to me winning this Nobel Prize, which I stole from one of my guests who's on the show, Frank Wilk. No, it's a piece of chocolate for Hanukkah. But anyway, so I want to take these meteorites, send them to you or somebody. They have to be melted at extremely high temperatures. So you're going to have to look up, melting iron basically. But if we can do that and mold that, we can we can make a serious amount of money, and it would be really powerful to do that for people around the world, to have a fragment of 4 billion year old space dust to remind them every day that they're mortal.
It's just to show, it's like this one that you gave me, it looks like a peace sign. I don't know if you can see it in there.
That's right.
It looks like a peace sign. So I
or a shakalaka.
Yeah.
I wanted to like shakalaka for you to come surfing out here.
Yes. Oh my gosh. That's my favorite sport, is surfing. I would love to.
It is so awesome out here.
So for me, there's nothing better than surfing in sports. That was the best.
So talk to me about this. Yeah. I got this, and I'm treating it like, I'm treating it like, it's a data file from the Voyager spacecraft. So talk to me about what this is.
Yeah.
You sent me a note, but I want your listeners to hear about it too. It's so cool. I'm keeping it next to my data here. I'll show you what it's next to. Yeah.
So I gave them to people important in my life, and that have influenced me a lot. One of them, Scooter Braun, I'd send one to him, and Shay Mooney from Dan and Shay, and a couple of other people. So I just made 10 copies. Oh, and my friend Tribby as well. So I made 10 copies of it, and it's literally just to show my progress and growth. I've been producing music since I was literally 4 or 5 years old, just like recording on a tape recorder and trying to figure out how microphones were working. I used to rig my headphones in reverse, and I would record my guitars with that into like sound, whatever it was with Windows, like the first Windows, they had like the sound recorder.
Windows Media Player.
Media Player, yeah. And so it's just my evolution, my growth, because, you listen to my stuff now, has nothing, like all that stuff that's on the tape is probably, to me, it's garbage. So that's why I started a podcast. It's called Producer Trash. And I had the idea because I'm just like listening to all those songs from 10 years ago. And I'm just like, oh my God, this is trash. Just horrible. So, I just wanted to kind of mark my, to somebody that would keep it as well, to, my growth, so I can look back at it in 10, 20 years as well. So that's what
very much
that's what the tape
treasure
is.
That. Yeah.
Thank you.
So this is from 2018, I see.
Yeah, it starts off in 2008, and so that's my songs from 2008, and I stopped making those kind of songs in 2018, and it's just there. So it's an archive tape, basically. Yeah. And I think I get you 5. Yeah, and then broken on purpose. Yeah, because the thing was broken, so had to put some artwork on it, you know. But yeah, I started making electronic dance music, which is kind of the form that and ambient music. I had another side project, and trying to, you know, there's like a scientific aspect of it. Is, you know, I'd kind of use like the scientific method to develop songs and figure out what's working. And so I started in Iraq on my laptop, you know, trying just to get down, you know, oscillation and how oscillators work together and frequencies and making tones and all that stuff. So yeah, just kind of been growing from that, and now I'm just more in I think I'm more evolved, and now I finally get it. I think I'm on day 1 every single day of my music journey. I'm just like, oh, well, I'm brand new, you know.
Yeah, that's the beginner's mind. You gotta have it. It's,
absolutely.
You know, that to me is the true key. You've got to maintain kind of a humility, being humble, and in science too. Yeah, that's the scientific method. If you ever get haughty or whatever, it's that's the end. You're not gonna possibly be able to succeed if that's your notion of where you're at. Yeah.
I always feel like it's just day 1, and also you know, and it means a lot to hear back from you on the songs and things like that too, because it helps me.
I love it.
Like
yeah, I'm putting them on my podcast.
Direction. Cool. Thank you.
So I'm hoping you'll take. So I'm hoping I can get a copy of this video after we're done, and I want to put it on my channel today.
Awesome.
As a little kind of bonus track for my listeners, and then maybe we'll add some music to it or whatever, but keep it there. But then you got to answer my questions.
Yeah.
You got to answer my final 3 questions. Are you?
I'd love to.
Tell me when you're ready for that.
Well, I always have different answers every single time that I listen to it, and I, you know, kind of self-explore.
It'll be a snapshot. It'll be an archived podcast.
Yeah,
so
an archived
in
podcast.
10 years we'll come back and we'll listen to it.
Yeah.
All right, you want to do it now? Should I ask you my final questions?
Yeah, let's do it.
Awesome, man.
And you kind of
all right. So
on me.
just for your audience, so I run this Into the Impossible podcast on Apple, and I run Dr. Brian Keating, Dr. Brian Keating on YouTube and Twitter and Instagram. And my thing is that I want to ask the greatest minds and the greatest creative people that have influenced me, that inspire me. I literally listen to Miguel's music when I got a big project. I turn on distraction-free mode. I start typing away, and I just go into another place. My wife jams out to it. She's a big fan, former Denverite too.
Awesome.
Denver Center. I don't think exists anymore, but anyway, we asked these great performers, ranging from billionaires to submarine commanders to you know, startup entrepreneurs, people like Noah Kagan, Jordan Harbinger, James Altucher, trying to get Mark Cuban to come on the show, and then 8 Nobel Prize winners, Pulitzer Prize winners, and I asked them these questions that I think will be evocative of their personalities. Because what I want most, the stereotype of a scientist is someone who can't even look at, you know, your shoes when he talks to you, right? It's he can only look down at his own shoes. So for the scientists, I want to get them out of the shell and make them more like the entrepreneurs. And for the entrepreneurs, I want them to think more deeply about the big questions. So I found these 3 questions really tie into what makes people unique. So I'm going to start off. You ready, Miguel?
Yes, let's do it.
All right. Can you provide in 3 sentences or less a unification of quantum mechanics with gravity that works in 16 dimensions or more? No, I'm just kidding. That's not one of the questions. I just wanted to stump him. Got to stump you. All right. First question. There's a concept in my religion, in Judaism, of an ethical will. Okay. And as I talk about in the book, Alfred Nobel had an ethical will. He had a material will that he wanted to give money to people to actually make the world better. In addition to this golden medallion that they get, he said you have to discover or invent something that benefits greatly all of mankind. Okay. So it was an ethical will. It wasn't just what he wanted done with his money. In Hebrew, it's called a zava'ah. And I want to know, for people, I don't think you don't have kids, right? So it's a little, I got enough kids for both of us, but you got siblings and you influence them, I'm sure. and they probably look up to you as a role model, as I do. I look up to you, and I honor what you've done for the country and for the world and for me personally. But I want to ask you, what do you want to give to the world, not in terms of your money or your artwork, but something intangible, non-physical, that will outlast you in term and benefit mankind in the same way that, say, the Nobel Prize did, in terms of your ethics, wisdom, or morals?
I would have to say, if a feeling doesn't count as a substance, it's just like the feeling to be and to do good. You know, and to pass that on through, you know, you can do that through example. So I would say that the feeling.
That's great.
Because I mean,
That's
if
wonderful.
everybody can feel that, you know, it would,
Yeah,
I think it would resonate. So
that's wonderful. I don't know if you ever saw the movie 2001: A Space Odyssey.
no, I haven't.
It's a movie that I
years.
recommend people watch. It's an old movie. It's actually way older than 2001 even, but it's about kind of the progress of humanity from, you know, the primates on the savannas of Africa all the way up through, you know, the space age and landing on the moon. And there's an obelisk in this that kind of looks like this tape, but black.
Okay.
And it appears in different contexts. So or initially these cavemen and women find it and are hitting it with a bone and they don't know what to do with it.
Yeah.
And then later they find it on the surface of the moon when NASA sends astronauts to the moon. And it's clearly meant to be like a time capsule that can last 1 billion years.
Okay.
And I asked Carl Sagan's widow. So Carl Sagan's widow is Ann Drury, and she runs the Cosmos program on TV with Neil deGrasse Tyson, my kid's favorite astrophysicist. Yeah. And Carl Sagan and Ann Drury actually did this. So she said, I put a golden record on the Voyager spacecraft, and that Voyager spacecraft has music, has a disc made of solid gold that has music from all these cultures around the Earth. And actually, Miguel, this was the first example of what's called world music. Sorry, ethnomusicography and world music. So I encourage you to look it up. But
yes, I will.
I want to ask you, if you were going to make a time capsule like the Voyager record that lasts for 1 billion years, she said, what would you put on it? What would you put in it? Would it be one of your songs? Would it be someone else's songs? What would you put on it for a future civilization to discover 1 billion years from now?
Selfishly, it would be my music. And
of course,
the reason that I would answer that is because when I write music and when I write poetry and when I'm writing my book as well, it's, for me, it's just like, that's just a stamp of what's there, but also shows what people are going through in general. And, you know, not to be like, oh, this is humanity. It's just from my perspective. And I don't know how anybody else's perspective is, so that's why I would just leave my music. I would leave it specifically on my Roland SP404 SX, which is a sampler that's super powerful, and I can load all my songs onto it. And I would put a pack of batteries in there, so double A's.
That's right. You know, if they get this thing, you know, they're not going to know what to do with it.
so yeah, I mean, if you're looking at a capsule like that, for me, it would be, to document history. So, you talk about in my time, Iraq, you have Afghanistan, and you got Standing Rock, which was very important for me. I was there during that time, and now you have these protests, and things like that. So, yeah, I'd put my music in there on a SP404SX. Final answer.
Awesome. Very good. And the last question has to do not with going forward in time like those other two questions, but going backwards in time.
Okay.
So Arthur C. Clarke, who is the namesake of the center at UCSD that I co-direct, it's this Arthur C. Clarke Center for Human Imagination. He had three famous laws. The first one is any sufficiently advanced technology is indistinguishable from magic. His second law was for every expert, there's an equal and opposite expert. Yep. And his third law, and I've had on Ben Shapiro on my show, and I've had on Noam Chomsky on my show.
That was a great one.
You got to get a doll of him. Yeah, he's great. So I got a doll of him. I got all these dolls.
Yeah, those are cool.
But I want to ask you, his third law is the only way to find out the limits of what is possible is to venture beyond into the impossible. That's the name of my podcast. So I want to ask you, what as a 20-something seemed impossible to you, Miguel. And yet, because of your courage and fortitude, became possible and allowed you to see the limits and the boundaries on what is possible for you. Advice to your former self.
I'd say for me, it's physically nothing's impossible, but mentally, I'm still discovering those boundaries. You know, like how can I conceptualize what the beginning of the universe was or looked like? How is
Me too.
sound? You know, how is sound? Like, what's dark matter? You know, what is consciousness? You know, and those kind of things. I would say to myself to explore those more deeply and not be focused on the physical limitations, and
Great.
traverse the mind's universe, multiverse.
I call it the mental multiverse.
Yeah, that's what I call
Miguel,
it.
awesome, man. Well, we're brothers from another mother. I hope to meet
Absolutely.
you someday.
Yes.
I'm gonna sign off. I want to ask you, where can people in my audience find you?
Okay.
First of all, where are you located online, and where's your other? Where can people find and buy your art, etc.?
Awesome. YetiTears.com, YETITEARS.com. And all my social media platforms are YetiTears.com. I did have one more question for you about,
Yeah.
I literally wrote it down, the legacy box question. I was like, hey, I just wonder, is it your book? What would you put in the box?
Ooh, that's a good question. For me, I think, I get a lot of my values from the Old Testament, from the Torah, the Bible. And I think, my legacy, I always say there is one and only one proven form of time travel, and that's, children. And that doesn't mean biological children only. It could be adopted children. It could be ideological children. My graduate students are every bit as close, to me as some members of my family, maybe more so.
Right.
I spend more time with them, than my cousins, who I love so much. But the point is, you can influence people, even if you're not a parent, to transmit your values into time, into the future. You can't go back in time, but you can go forwards in time. And so I'd most want to, kind of transmit the values that it's what you do outside of the laboratory or the office or whatever. That's where your legacy is made. And you want to live, kind of a humbly and with the understanding that, yes, you are going to be dust, but you're conscious dust. You're dust that is unlike any other dust that's ever existed, and make use of this precious sliver of time that we get between two dusts.
All right, Dr. Keating, well, I just want to thank you for your time. Everybody go pick up the book, Losing the Nobel Prize. It is, as science says, riveting, and I enjoyed it very much, and I appreciate you, and look forward to speaking with you in the future again. Thanks, Dr. Keating.
Thanks, Miguel. Yeah, let's talk about our next project to make a ring of meteorites and and some lunar dust paintings. That's what I want next.
All right, let's
have a great holiday season, Miguel. Thank you so much for having me on. And yeah, send me a link to send me a download link for the video so I can upload it to YouTube.
Absolutely. Thank you.
All right, brother. Be
Bye,
well.
everybody.
Thank you so much.
Thank
Bye.
you.